Hey guys, GCSE Trigonometry Revision, and here is the problem 8 as I promised. That's again circles and circles involving trigonometry. Alright, so make sure you remember all the properties related to circles and we start working on it. So guys, as normally you should do, you need to pause the video, try to do by your own, and let's compare it with my explanation. So we'll go to next slide and what we have here. So we have the following case. So we've got the circle. Let me set up the font style. All right. So you've got a circle centered in A, and you've got BC, which is the chord. So what a chord is? So that's the chord. So what chord is? By definition, is any basically segment connecting 2 points on the circle. So if the chord goes through the center, so it means connect 2 points and the center and the straight line, so that all 3 points are collinear. In this case, what is called all 3 points to be collinear, they lay on one line. In this case, segment and chord becomes diameter. All right. So that's like definition of chord. So we have the radius, which is 10. So let's try to simply define the size, and we have 7 for chord. Okay, we've got 7 meters here. That's BC, and we've got the radius, let's say AB. So AC as well as the radius, so we've got definitely the same size if we consider the triangle ABC, and a radius of 10 meters. All right, so basically we have triangle with all 3 sides now. What we need to figure out, we need to figure out the size of the angle BDC. So that's what we need to define. Let's set up as x degrees. Okay, so what sort of angle? First of all, let's consider the definition of that angle. This angle is inscribed because look, BC is the chord, basically support that supports your angle, and angle itself BDC is going to be inscribed. So that angle is inscribed. So inscribed is any angle that have the chord as like ending points of that of the arms, and the center of the angle, or basically the vertex of the angle, should be on the circle. In this case, it's inscribed angle. Okay, so what's the connection of inscribed angle and the central angle? So where is the central? The central angle should have the same BC points as supporting points, and that supports the arms of the central angle is AC and AB, so the central angle should have the vertex at the center, and that's the central angle. So what can you say about how they connected? So inscribed with the central angle is always twice more than the measure of inscribed. That's the main properties that we're going to use here. So 2 times more than inscribed angle. In this case, we can set up as 2x. Okay, so I'm not going to denote on the picture, so I'll just say that CAB is going to be twice more than x that we have here. Okay, so 2x basically. Okay, now we need to find the way how we can figure out the angle measure. There are 2 ways how we can do it. The first way is to consider triangle ABC. So we'll go in the very first way, we can consider triangle ABC, triangle ABC. Okay, it's equilateral, so we know that 2 lateral sides are going to be the same. We know that 2 angles at the base is going to be the same, so the base is 7. However, we apply the cos rule, which is actually applicable to any triangle, not necessarily right angle. So how the cos theorem works for any scalene triangle. So I can draw any scalene triangle and show you how it works. For example, here, one side, the second side, and the third one. Okay, we have any scalene triangle. We have two sides, A and B. We have the angle between them. Let's say the angle is going to be x. Okay, so from where we can figure out the length of the side if we know A and B lenses. All right, so if we know A and B, we know x, we can figure out the C length, so the opposite side. So cos theorem works as c squared is equal to a squared plus b squared minus 2ab times cos of the angle x. So that's the theorem for the cos theorem that works for in order to define side. From where, if you know all three sides, definitely you can rearrange so that you can define cos x, from where you can define x. Okay, so let's apply this theorem. I'm not going to explain because I already explained in previous videos, so make sure you watch them. Okay, this way we can apply this in order to figure out x. But guys, this is the longer way and maybe less convenient because maybe you can figure out cos theorem. Okay, so that's why it's better to find right angle triangle, and I'll show you a bit later. So right now let's accomplish that. We have two sides A and B as 10 and 10 because we have 10 meters on both sides, right? And we can say that c squared is going to be 7 squared will be equal to 10 squared plus 10 squared minus 2 times 10 times 10 times 10, 100. And we are going to multiply by the cos of the angle 2x. Remember, that's 2x, central angle. So times cos of 2x. All right. So how to figure out from there? You just simply need to rearrange so that to determine cos 2x. Okay, so that's 49 here. That's 200 in total. So we can transfer negative 2 times 200 cos 2x to the left hand side. So we've got cos 2x times 200. Okay, and on the right side, now it's positive. And on the right side, we've got 200 minus 49. So we've got 151, okay? So from where cos 2x is going to be 151 over 200. So guys, this is, you see, this more complicated way. So I just show you so that for fun maybe, so that you can estimate the length of the time required for that. Okay. And by the way, we have double x, double argument. So we need to find 2x first. So from where we can say that 2x is going to be cos minus 1, inverse cos of the fraction. So the fraction is proper, it's less than 1. So cos 2x is less than 1, that's okay. So now let's do this. Our cos of 151 over, sorry, my bad, it's going to be 200 here. It's writing. Okay, yeah, so over 200. 151 over 200. And we've got the answer, which is 40.97 degrees, 2 decimal place. And if we divide that by 2, we'll get the answer for x. So because right now we've got 2x, and now x as the final answer is going to be 20.49 degrees. Okay, so that's the final answer, but you see the complexity. So this is not what I recommend. Okay, so pause the video, try to fix that interim picture, and we'll go to the first pretty like nice and lean method. So that's why I just go back to the previous slide in order to have both solutions right there. Okay, so we have, one more time, what we have, so both lengths the same, so this is the base 7 meters, so we've got 10 meters and 10 meters, and we already established that we need to find first that angle, and then we can define angle which is x. So that angle is going to be 2x. Okay, that's 2x. But I'm not going to write this, so I just write as angle BAC is going to be just 2x in degrees. Okay, so the fast track, what do you need to do actually? I use the line that goes down, and that is going to be bisector of the angle A. In isosceles triangle, you just need to remember that bisector makes two angles the same, and by the way, also it should be height in this triangle ABC. So in triangle ABC, we've got the segment, let's say new letter, maybe what we can do, we can say that we shift a little bit 7 here. Oh, okay, even better to drop the segment. Okay, we mark the letter, let's say D. Oh no, we have already, so let's put K, and we say that triangle ABC is isosceles, so we can say that AK is going to be bisector. Okay, and also it's going to be the height, so it will arrange 90 degrees angle. So let's consider triangle AKC then. So we've got that. What we can do, we have this angle small is as x because of bisector it splits angle A on two equal parts, so that one angle is x. So basically we have triangle, I just show here, which is right angle, and let's see the sides that we have. So that's going to be the vertex, that's C, let's say, and this is K. I just draw this triangle from scratch, and now here we have K as the right angle. So we have half of the angle A of the full angle of full central angle is going to be 2x, and now we have half of that, so it's x. So what about sides? We've got this as the radius, we've got KC, the total length for KC is going to be 7, right? 7 meters. So because it's also median, so AK is not only bisector and height, it's also median. So median splits the opposite side where it puts on actually on two equal parts. So we can say that two segments are the same, and hence KC is going to be 3.5, half of 7 meters. So we have two sides, we can find the angle x. So that's a bit more preparations in comparison with cos, right? Cos theorem, but however, like it's a general way and you can work it out quite fast. So I'm just wasting my time for explanation, but anyway, you can do it much faster. So what about x? So we can arrange sinus, because that the opposite side, so 10 meters is height, so we can arrange sine of x, which is going to be 3.5 over 10. So that's the fraction. So in this case we're going to find, and that's okay, it's less than 1, so the test has been completed. So we can figure out angle x itself. So it's sine minus 1 of the fraction 3.5 over 10. Okay, and we've got immediately 20.48 degrees, 2 decimal place. So if you compare with, so that's the solution for the problem. So if you compare with answer that we've got using Pythagoras, actually you'll get the same. So let's check it. So 20.48, so 20.49. So a bit more like a bit more, you know, the difference is in the second. Oh, actually, yes, that's my bad. I forgot to round up. So if I round up, I'll get actually 49. So now they are the same. They are the same. So to 2 decimal place, both method works in the same way. Okay, so we've got the same result. You may compare. Okay, that's how it was done for the circle. So make sure you've got both ways. So that's the first one. Using right angle triangle, and actually I encourage you to do to find this triangle and figure out trig ratios. And also if you go here, so make sure you know how to apply Pythagoras, how you can apply basically cos rules. So that's about that, and this is the way. Okay, so that's how it can be done. So you guys, it's up to you which way to choose, but as any science tells you, you need to find and you need to apply the very short way, actually, and the clearest way. Hope you understand this and hope you like that. Don't forget to subscribe if you're new here. Don't forget to smash the bell button to be notified about all latest updates. So our videos, actually, I create videos and they actually appears every single day, so that to cover as much as I can. That was Daniel Dallas. See you later.